Okay, so we have another couple questions here to do. I'm actually going to add on a little extra on this one, and I do want to give domain and range as well. So I'll have an A, B, and A, B, C, and I'll kind of add on a little bit of a D here, where I want D and R, domain and range afterwards. But let's just take a look. What does the data on each graph represent? So we have graph 1 and graph 2. Identify independent and dependent variables. Why are the points connected on one graph but not the other? And then obviously the thing that I just added, domain and range. So let's take a look at our first graph, I. First off, what does this data in this graph represent? Well, let's take a look at it. We have on the y-axis distance from school in kilometers, and on the x-axis we have time. And graph A is saying the distance of the school bus from the school. So we want to describe what is this data actually doing, what does it represent? So I would think that as time increases, the distance that the bus is from the school goes down. And you can see that it starts at 8 o'clock, it starts at, just under 16 kilometers. But then at 9 o'clock, theoretically, I guess when school has started, or, just about when school is going to start, at 9 o'clock, it is 0 kilometers from school. So it would be at school. So let's kind of put this down. As time increases, we always want to relate our domain first. As time increases, the school bus travels closer to the school. You can go on and explain, it's starting and it's stopping. Like it starts this many kilometers away at this time and it ends at the school at 9 o'clock. But we don't really have to do that here. We're just kind of describing what does this mean. Let's go ahead and let's answer the same thing now for the second graph. Okay, first off, number of students. I see that number of students on the y-axis, and I see the time as well. So it looks as though that as our time increases, our students are going up, but it looks like at 9 o'clock, there's 0 students. So it's very hard to give what is the data doing over here, but it does look that at the beginning, as time increases, again, relating our domain first, the number of students on the bus increases, but at 9 o'clock, there are no students on the bus. Good. So A, good to go. What do each data represent? We got those two for those ones. Let's go ahead and let's look at B now, the independent and dependent variable. So for I, the independent variable would be time. Independent equals time, and that is measured in, it looks like hours. Measured in hour. For our dependent variable, let's go ahead and let's go this. Dependent, this is going to be the distance from school. And it looks like the variable that they're using there is going to be, or the measurement that they're going to be is in kilometers. Now, it's asking for the variables as well, so I'm going to say that the variable for this one looks to be D. And the variable for this one back here looks to be T. So T and D. For our second one, our independent, and I'll just do this one first, is again time. And that is in hours. And our variable that they're using is T. For our dependent variable, you know what, I won't even bother putting dependent. We know what we're doing here. Dependent, it is going to be number of students. And they are measuring that as n. Okay, so that would be our second one. Good to go. Why are the points connected on one graph but not the other? Okay, so see, the points are connected here because as time increases, the distance will go down, and it's going to be a continuous relation as time increases. The distance decreases, or you could say travels closer, doesn't matter. The distance decreases continually. So decreases continually. There's never some big jumps. This bus is not teleporting from one place to another place. It is traveling there, so it's continually decreasing the distance between it and itself and the school. However, for our second graph, we are not continually increasing student count in terms of there's not 0.5 students gaining every minute or whatever the relation would say. We can only have whole numbers of students. So that was for I, but for double I, we can only have whole number of students. So this would just be discrete data here, and we would have over here, this would have continuous data. So connected for continuous and not connected for discrete. Very last one, we wanted to do domain and range. So for the domain, for our first graph over here, we are starting at 8 o'clock and we are going towards 9 o'clock. And we can be at any point in between these. So what we would say here for my domain, I would use a square bracket and I could say 8 o'clock would be my starting value and 9 o'clock would be my finishing value. And again, I could equal these values, so I would have square brackets square brackets over the 8, square brackets over the 9. If I wanted to, I could say this in a different set of notation. So I could say that my domain would be something like this, where my t values, the variable that I'm representing, are such that my lowest time value would be 8 o'clock. That would be having to be less than or equal to t, which is less than or equal to my absolute highest value here. And I would use my curly braces for that. Regardless, this or this could be the domain. Afterwards, I would then say that my range, and let's do that in a different color, my range, I will say that my range is going to be, it looks like just less than 16. So we're going to go from 0, we always go increasing, 0, all the way up to, and let's go ahead and call that, this would be 14. I think 15 would be fine for that. And that would be it. Or we could do this in our set notation and say that my range is my distance such that my lowest value, 0, is less than or equal to my variable is less than or equal to 15, and close that off. Let's do the domain and range for the other one. Now in this case, I really don't have an option of what I can do. I only have discrete values here. So I would actually have to use, open up a set of curly brackets. It looks like 8 o'clock is my first value. It looks like 8:15 would be my second. 8:30 would be my third. 8:45 would be my second, or my second last, sorry. And then I would have 9 o'clock as my last value for my domain. There is no other notation I can use. This is the only one, since it's all discrete values. And it looks like they're all going up by 15 minutes, that is. My range, on the other hand, we would go for, starting off with the lowest value would be 0. Then going to, it looks like just less than 4, so I'll say 3 here. We would go to, that would be 12. This would be a little less than 20. I'm going to go with 18. And then we would be at 28. Oh, not 30. 28. So I would just need to make sure that I'm doing this in ascending order. We always go lowest to highest, and that would be it. And that would be all of our domain and range. Kind of a long question, a lot of stuff to look at, but just make sure you know the difference between graphs that all have the points connected and the graphs that are discrete, and how to actually read the graph. Like, what does this data actually represent? Big question on the final exam for you guys to make sure that you know how to read graphs, and always make sure that you're relating that domain first as time increases. That's always relating the domain to that range. And that's it.